Hi, welcome to the last section, QGIS scripting. We will start off this section with layer loading and management, followed by an exploration of the vector data structure. Next, the programmatic launching of other tools and external programs will be covered. Lastly, the QGIS map canvas is covered with respect to how a script can interact with the map canvas and layers within. Now we move on to the first video of this section, loading layers. Here, we will manage rasters, vector files, and database vectors. Loading layers in QGIS involves different steps. First, load the layer. This step creates a variable with the layer information and related data. Then, register the layer in QGIS so that it can be used by other QGIS tools. Loading a layer means loading a reference to the layer and its metadata. The layer is not necessarily loaded in memory, but is usually fetched only when data is accessed to be processed or visualized. Every layer type is managed by a provider manager. QGIS has some internally implemented providers, but most of them are external libraries. The list of available providers depends on the QGIS installation. This list can be obtained by typing this code in the QGIS Python console. The result shows a Python list of strings that have to be used when a PyQGIS command needs the provider parameter. Like most free software projects, the QGIS community doesn't want to reinvent the wheel if it's not strictly necessary. For this reason, most raster formats that are managed by QGIS can be loaded thanks to the GDAL library that is documented at gdal.org. To code the loading of our first raster named landcover.img that is available in the QGIS_sample_data folder, execute this code snippet in the QGIS Python console by adapting the path to landcover.img based on your operating system and data location. In this way, the layer is loaded and referred to with the myRaster variable. If we want the layer to be visible in the legend with the name myFirstRaster, we need to modify this code by adding a second parameter, as shown here. One of the basic actions after loading a layer, raster or vector is to ensure that it has been loaded correctly. To verify this, execute this command. It should return true if the layer has been loaded correctly. To recover some actions in case loading fails, we use this code. Next, we will explore QgsRasterLayer. The myRaster variable is an instance of the QgsRasterLayer class. This means that all methods of the raster are documented. This class is a specialization of the generic QgsMapLayer class. We can get some raster information by calling the methods using this line of code. It will produce an output as shown here. To get the extent of the layer, it is necessary to use the extent method of the QgsMapLayer class, so execute. This will generate a strange result. This shows that the result of the extent method is a QgsRectangle instance, where it is possible to call all the methods belonging to QgsRectangle. For example, the bounding box coordinates can be printed with this code. This will produce a result as shown here, showing the minimum and maximum values of x and y. Finally, we can visualize the raster using the centralized QGIS layer manager called QgsMapLayer Registry. This class is like the hub where we can manage layer loading and unloading. It's useful to read the list of its methods in the QGIS API documentation. QgsMapLayer Registry is a singleton class. This means that it can't be instantiated multiple times like QgsRasterLayer. For example, we can have different loaded raster layers and each one is an instance of the QgsRasterLayer class, but it's not possible to have different QgsMapLayer registry instances. This is because it is blocked by code and it's possible to get only the unique instance using the instance method. Finally, to visualize the layer, we have to execute this code. This will produce an output. After the layer is loaded, QGIS will appear as shown. This displays the image loaded in QGIS with a default false color rendering palette. Similar to the raster layer, most of the vector formats managed by QGIS are supported by the OGR library, a part of the GDAL library. OGR is documented at the same link of the GDAL library. All vector formats managed by OGR are listed at gdal.org. To read vector data, it's always necessary to specify the provider because it can be provided by different sources. To code the loading of our first shapefile named alaska.shp that is available in QGIS_sample_data, execute this code snippet in the QGIS Python console. This way the layer is loaded and referred by the myVector variable. After adding the layer to QGIS map layer registry, it will be visualized in the legend with the name myFirstVector. In the QGIS vector layer constructor call, it's possible to find a third string parameter, OGR, that specifies to use the OGR library to load the alaska.shp file. As usual, we will check whether the loaded layer is valid using this line of code. The layer is now added to the map. If vector data is hosted in a spatial database, it can be loaded by specifying the location and connection information using the QGIS data source URI class. A URI is how a resource can be identified on a network like the World Wide Web. The code snippet is used to fill the URI with the necessary information to connect to a remote spatial database as PostGIS. The first line creates an instance of QGIS data source URI that is filled with other information in the next lines. The setConnection method accepts the IP or the symbolic name of the database engine, the connection port, the database name, the username, and the password. If the password is set to none, QGIS will ask you for the password for connecting to the database. The setDataSource parameter refers to the schema name, the table name, and the geometry column where the geometry is archived. Finally, an optional where string could be set to directly filter data, in this case, mywhere. The last line shows you the URI string that will be used to point to the vector data. It will be a string similar to this line. An alternative way is to create the URI string manually, rather than populating the QGIS data source URI class. If the database is on Spatialite file, it's necessary to substitute the setConnection method with this code. This generates the URI string as shown here. In this video, we managed rasters, vector files, and database vectors.